Okay, today we go to the first one, implicit function. So, implicit function, you can see this is the implicit function. Let f be a function. So, f is a function. Two variable x1. F be a function of two independent variable x1. So, given by fxy equals c. C is a constant. So, c is a constant. So, to determine the derivative, we want to find dy dx. So, implicit function first. First step, we let z equal fxy equals c. So, our z equal this one. Fxy equals c. Yeah, f is a function, independent variable x and y. So, z equal f. Xy then equal c. This is the first one. So let this one equal fxy equals c. So next we differentiate. We differentiate our z, this one, respect to x. We differentiate z respect to x. So you use change of variables. Still remember, we use change of variable. We can build this one. Del z del x dot dx plus del z del y dot dy dx, because your z function also got variable xy, because z equal f. F is a function of two independent variable x and y. So del z del x del z del y. So this two. We got two. So we use change of variable. We use change of variable. We will got this one. Change of variable. Then equals 0, y equals 0. Because we differential constant. Del z del x, this one. Differential z respect to x. You also differential c respect to x. So you differential constant, you will got 0. So your c you differential, you will got 0. So this is why your right hand side equal 0, because constant. The equation z equal fxy equals c. Then we differentiate. The differential whole equation respect to x. So you differentiate this one whole equation respect to x. So del z del x. Then this one is used change of variable. Then equals 0 because we differential respect to constant. So differential constant, we will got 0. So after this, we rearrange this part. So after we got this co-equation, we rearrange this one. We rearrange. We want to find dy dx. So this one, dx, you will got 1. So you apply dy dx, you will get this one. So dy dx. Dy dx, you rearrange, you will got this. So this one is implicit function formula. Dy dx is equal negative del z per del x divide del z per del y. This one is the general formula for your implicit function. This is how you build your implicit function. So if the question wants you to solve one equation equal constant, then you can direct, want to find dy dx, you can direct use this implicit function, this one. You can use direct, no need to show how to build. You direct use only. And you can see your formula here got negative. So every time when you apply this formula, don't forget your negative. So dy dx equal negative del z per del x divide del z per del y. So implicit function. So this one is implicit function. So this is our formula, our equation. X power 2 plus 2xy plus y power 3 equals 0. We want to find dy dx. So this is our fxy equal constant. Now our constant is 0. So if here they can also then any number, x power 2 plus 2xy plus y power 3 equal 10 is also same constant. 10 is a constant, or negative 10, negative 2, any number is okay. That one all is constant. Okay, we want to find dy dx. This one we know we will use implicit function. So you can see if the question give you is y equal x power 2 plus 3x. So if this one, this equation, y equal x power 2 plus 3x, this equation no need implicit function. No need implicit function to solve, because y equal x power 2 plus 3x, this equation you can direct find dy dx. Because one side only y, then another side is function, variable is x. Variable is x. So your equation is x only, variable. So y equal. So if you see your example 1.4, this one, you cannot one side x, one side y. You cannot find. You rearrange, you cannot write y equal your x function. So if cannot write like this, we will use implicit function. This means that you cannot direct find differential dy dx direct. So this is why we use implicit function. If you want to apply direct dy dx, your y function y is only y, one side, then equal. Then your x here is x variable, any variable. Your x can power 3, power what, any. Your equation in x. So if you cannot write in this form, one side y, one side equation x, so we will use implicit function. We will use implicit function. So this is why we use implicit function. So for this one, first step, we let our z equal. This is the first step. Let z equal the equation we want to solve. Then, now we apply formula. You can see your formula. So del z del x. So del z del x, del z del y. And negative. So our formula, we direct apply this formula only. So first step, we need to find del z del x. So first step, del z del x, del z del y. We differentiate z respect to x, and differentiate z respect to y. This one is basic differential. Then after this, you put into your formula. Then remember in front got negative. So negative del z del x del z del y. So this is our answer. This is our final answer. So this one is implicit function. This one is implicit function. So got problem. This one okay or not?
Okay, okay.
So this one is our implicit function. So you can see the exercise. Okay, this one, exercise 1.3. Given, same, you can see this one. Our function, then evaluate dy dx at, you can see now, this one, extra, at 0, 0. This means that your value x equals 0, your value y equals 0, 0.00. So this means that if your equation got x and y at the end of your answer, don't starting, you direct reply xy equals 0. No. And your final answer, yes. Your final answer in xy, you replace by 0, 0. Here is give you 0, 0. If 0, 1 is x equals 0, y equal 1. So based on your question. So now it's 0, 0. So for example, this one, same question. So here, and they also say 0, 0. Even function, therefore dy dx at 0, 0. So we can replace here after we finish this one, finish already. So then dy, so dy dx 0, 0. Now you can replace. We finish this one first in xy, then dy dx at point 0, 0. So now this one can replace by 0, this one can replace by 0, this one can replace by 0, this one also can replace by 0. So, and we will got final answer 0. So, and we will got 0. This is the meaning. So, we will got 0. This one you must show before go to final one, 0. So, this one is your UIDX in variable xy. Then this one is dy dx. Your variable now xy replaced by 0, 0. This is the meaning. So if you find your question cannot skip this one cannot skip. You must show that and you will give your final answer is this one. So now try this exercise. See you got your answer -1. I give you 5 minutes. So you can try now. See your final answer got -1 or not. So do now. you can find the answer. -1, got problem or not?
Ongoing, madam.
Okay or not? So if no problem, we will continue to the next one. This one is implicit function. Direct only the question. You can see the direct only the question. If you cannot solve directly dy dx, so we will apply implicit function. So now is Jacobian. So Jacobian, this one is in n variable and n function. You can see this one is variable. So until n variable, then this all is function. So n function. This one is general one. N variable and n function. And for this one, so j equal. Then you can write this form or this form. This one is okay. Only the determinant. You can see determinant j Jacobian equal j. This t is transpose. So j equal determinant j t. So j equal j3. So same. Will give you same answer. J and J transpose. Jacobian and Jacobian transpose will give you the same answer. So this one will give you same answer. So what is the meaning? So now we go to Jacobian. So Jacobian. Given u equal exponential x cos y and v equal exponential power negative x, then sine y. So here is two function u and v. Two function. Then we want to find Jacobian. So j equal del per del x, del u per del y, and del v per del x, del v per del y. This is Jacobian. So this one also can. If j t for this one, so you can write del u, del x, del u, del y, del v, del x, del v, del y. Your J or J transpose will give you same answer. You can choose any one, it's no problem. You can use this one, you can use this one to solve. Both is okay. Both will give you the same answer. Will give you the same answer. So this is Jacobian. So determinant J and determinant J transpose will give same answer. So you can use anyone. You can use in this form to find your J, or you can use this one to find your J. It's okay. It's no problem. So this one is not only one. So you can choose anyone. You can choose J or J transpose. Anyone. You can use these two to solve. Okay, this is the J and J transpose. So now, Jacobian. So this one don't skip. You write out. Then you differentiate U respect to X. So this one. You differentiate U respect to X, you will get this answer. So you differentiate this one respect to X. You differentiate exponential respect to X. You will get the same one. Then cos Y is a constant because here you differentiate X. So your cos Y is a constant. If U equal EX plus cos Y. This one is different. Here plus, here times. So plus and times is different. Multiply is different. So when you differentiate del U del X, this one you differentiate, you will become 0. If you differentiate respect to X, del U del X, if you differentiate cos Y, you go to 0. So your answer is only EX. But for our question, here is not, it's exponential times cos. So not exponential plus cos. So please, when you read your question, be careful. Don't give me your cos Y, you direct here. You give me 0. That one is wrong. Because for this question, you differentiate X only. Exponential X. Then another variable will become constant. So this one is the basic differential. Okay, the differential del U del X. So you can write out like this, del U del X. So your answer, del U del Y. Then your answer like this. One by one, you write out, then you put inside to your formula. It's okay. If you don't want, you can write like this. First one, you write this one. Then second one, you write your answer, you differential. Because I know this one, del U del X, is this one. Del U del X is the first one. Yes, I know. Then del V del Y is the last one, I know. So this one cannot skip. If you skip, you direct give me this answer, I don't know. You differential which one respect with which one, I don't know. So the first one you cannot skip. Make sure the step cannot skip. Because from here, I will know this one you differentiate is this one. The answer, correct or not? I can check it. So if you direct give me this one, I don't know. This one is what? You differentiate what? You direct give me answer, you do not show. Only you write out del U del X, another answer. Okay, so I know this one del U del X. Oh, this one del U del X, I know. If you don't write out this one, this out, I wouldn't know your determinant. This one, this determinant. How you create. So the item inside is what? So make sure. If you want to solve Jacobian, don't skip the step. So I know first one, first step, write out. So second step, we differentiate one by one. Here got 4. Because this one, or this one, you will got mark. If come out this kind of question, all your answer, you will got mark. If you skip, you all lose all your mark. So this is why I said don't skip. Because everyone we will checking, correct or not. You differentiate, you respect to x. And differentiate, you respect to y, correct or not. So then finish this one. We will go to the next. We solve determinant. So to solve determinant, so A, B, C, D. So A times D minus B times C. So follow this determinant. AD minus BC. So you will got this one. This is the form to solve determinant. You write out first. This one is not solved yet. This one is initial. You solve the step. How to solve your determinant. Then finish this one. We will start to solve our question. So you can see here, exponential times exponential. So EX times E negative X. So this one is equal exponential X times is plus. Times is plus for exponential. Then negative exponential negative X. So for exponential, the property exponential. So exponential X times exponential negative X is same. Exponential X plus. This one is this one times plus negative X. So you solve this one, you will get exponential 0. X plus negative X, you will get 0. Exponential 0 is equal 1. Don't give me 0. This one is equal 1. Exponential 0 will become 1. So this is why you got this one. Cos. Because exponential times exponential, this one times this one will become 1. So cos times cos is cos power 2. Then after this, if you want, you can stop at here. This one, we can stop here. Cos power 2, y minus sine power 2y. Because if you want to change this one to cos 2y, if you want to change until this one, you need to use trigonometry. You need formula to change it for cos sine. The formula. So if you want to stop here, it's okay also. So cos 2y, you need trigonometry identity to solve. You need property for your cosine. They got formula. So for Jacobian, got problem or not? So any question for your Jacobian?
Understood, madam.
So this one is Jacobian. This one will use. This one will use in inverse function. This one continue will use in inverse function. So make sure you know how to find your J, Jacobian. So now to solve this one, use Jacobian. So find, see you can find this answer or not. So now solve. I give you 5 minutes. 5 minutes, 5 to 8 minutes. See you can solve or not. So you solve now. See you got the
Madam,
final answer.
I want ask something.
Okay.
If
Yes.
we use the J inverse, also minus, right?
J transpose. Yes.
Ah, yeah, transpose.
J transpose. Yes. Because both will give you same answer. The J at the end. So you can use anyone. You can use J or J transpose. And will give you the same answer is no problem. So you can start to solve. So, okay, for exercise 1.4, you got the j equal y minus x.
Yes, got.
So, this one is Jacobian. This one we'll use in the next one, inverse function. This one we'll use in the next one, inverse function. So, now, this one is our inverse function. We direct apply the formula. So, this one. This is the formula for inverse function. So this one is inverse function. So if question give you del u, del x, so our inverse function is del x, del u. So this one, if the question u equal fxy, so like this one, u equal fxy. So you can find direct this one. Del u, del x is no problem. You can direct differentiate u respect to x. But for inverse function, this one is inverse function. You cannot direct. Don't give me, you want to find del u, del x del u, then you give me negative 1 per del u del x. No. For inverse function, no. So for this one, we can direct find del u del x. Then if we want to find del x del u is inverse function for this one, inverse function. So del u del x, the inverse function for del u del x is del x del u, inverse function. So if you want to find del x del u, you cannot direct give me this one. It's not 1 del u del x is not equal 1 divide del u del x. That one, this one is wrong. So if you want to find del x del u, you need to apply this formula. You need to apply the formula for inverse function. So if the question wants you to find inverse function, so please, you need to use the formula. So it's not 1 divide. It's your inverse function, no. So be careful. This is why we got the formula. This one is the inverse function formula. Is your inverse function formula. So the question, this one, you only can solve del u del x direct. You cannot find del x del u direct. This one is inverse function. You need to use inverse function formula. Inverse function formula. This one to solve. So this is inverse function. Then the j here is your Jacobian. The j here is Jacobian. Then you can see some inverse function in front got negative. The formula in front got negative. So when you apply the formula, don't forget to write out your negative. Maybe you differentiate correct, or it's correct, but forget your negative. So your final answer will become wrong. So this is why when you apply the formula, make sure, careful. If got in front got negative, write out negative. Then sometimes del x del u del x del u, they also can write like this, del x del u. Because still remember, del f, del x, the starting one. So differential respect to x, you write like this one. So same meaning. Don't say you don't know what is x. And small letter is a u. So same meaning, this one and this one. Like this one and this one same. Del f per del x is differential f respect to x. You can write in this form. So this form also same. Differential x respect to u. So for this one, differential y respect to u. They can give you the simple form one. They didn't write out del y del u. They give you this one. It's also same. Don't say you don't know. So I'll let you know first. They can write like this. This one and this one same. This one. Same meaning. The starting, introduction one. So this is inverse function formula. This 4 is inverse function formula. Then next, so when given u and v, then question 1 to find del x del u, del y del u, del x del v, del y del v. So you can see this one, we can direct del v, del x, or del v, del y. It's okay. But this one is inverse function. They want to find inverse function. They don't want this one. They want this one. Del x del v. So we will apply inverse function. You can see the question give you like this one. You can direct find this one only. Del v del x is no problem. You can direct find. But del x del v, the inverse one, that one you need to apply formula. So this is why inverse function we apply. We cannot direct find inverse function. We only can apply formula to solve it. So for inverse function, so this one inverse function, you need to find j first. J because the formula all involve j. Then the j we use this one. So you can see same one. U equal exponential x cos y. V equal exponential negative x sine y. So you find your j, we find our j, you got this cos 2y. So we apply this one direct. You can see same. Example 1.6. So this Jacobian is formula. Example 1.5, we calculate already. Now we apply our j. Because if you want to find del x del u, you need del v del y divide j. So this one is our j. Then dy del v by del y, we no need to recalculate because here del v del y. So here you copy only this one del v del y. So your answer for del v del y, this one. We copy only the del v del y. You copy, you calculate already. When you find your j, Jacobian, you find del v del y. So this 4, you find already. You can direct use, no need to recalculate. So the V, the Y you copy, then put into the formula. So the V, the Y, and divide check. So same, all this same, you only apply formula only. So you apply formula for inverse function, all put into in your inverse function. Because all this you find already when you find your Jacobian. This for first order one. When you want to find your Jacobian, when you want to use Jacobian, you calculate Jacobian, you need this 4. You find already, so we direct use. No need to recalculate. When you apply the inverse function formula, or substitute inside only. But make sure when you substitute, make sure correct one. Don't substitute the wrong one. So this one is inverse function. So this one got any question want to ask? Got problem?
I think no at the moment.